The prototype pattern essentially involves making a copy of one original object. It is useful when you want to create a new object but a similar one already exists. In particular, it should be used when you do not want a system to know details of how objects are created. Say, for example, there is an application that simulates a field of rabbits, and while the application is running, the rabbits breed. Instead of creating a new rabbit object each time, it would be easier and more efficient to clone a single prototype rabbit. This technique is particularly useful if creating a new rabbit object is a memory-intensive process. It can make the application faster, as well as make the code shorter and cleaner, if the prototype pattern is used and an original rabbit is copied. The copied rabbits can then be modified. For example, you could clone the original rabbit 10 times, and then give all of the rabbits their own name. This pattern should be used when the application using the cloned objects should not need to know about how an object is created. It is also useful when classes are loaded dynamically. For example, in an application that creates new rabbit objects as it runs, the rabbits are only created once the program has started running. This can slow the program down because new objects are being created all the time. But if the objects can be cloned, this will save memory. Having a prototype in this example is particularly useful because all of the rabbits have very similar characteristics. If the aim of the application was to create a different range of rabbits, with different names, ages, breed types, colours and weights, then the prototype pattern would be less useful. In that case, we could still clone a rabbit, but we would then have to execute a lot of code to change all of its characteristics each time. There would be little benefit of cloning over just creating a new rabbit object every time. In the classic prototype pattern, there is an abstract prototype class that has a method called clone. There are then concrete implementations of the prototype which overrides the clone method. A client can then create a prototype object and obtain copies of it. The most common way to implement the prototype pattern in Java is with the clonable interface. In this example, there is a class called rabbit. Rabbits have two characteristics, an age in months and a breed. There is an enum at the top of the class that specifies the different types of breed a rabbit could be. The class has methods to set and get the age and the breed. The purpose of the prototype pattern is to be able to make exact copies of a single rabbit object. For example, in the main class, a rabbit could be created and its age could be set to 2 months and its breed to Himalayan. Then, if it is cloned, the new rabbit should have the same age and the same breed as the original rabbit. In order to do that, the first thing to notice about the rabbit class is that it implements the clonable interface. Secondly, the rabbit class needs to override the clone method. Inside the clone method, a new rabbit is created by calling super.clone. The return type for the clone method is object, so this should be cast to rabbit. The next requirement of the clonable interface is that the clone method has to throw a clone not supported exception. If I do this, I will have to surround any code that uses the clone method with a try-catch. So an alternative is to use a try-catch here instead. If the exception is thrown, the code will simply throw an assertion error. Now the rabbit object can be cloned in the main class. To demonstrate this, inside the main method, the age of the first rabbit is set to 8 months using the setAge method in rabbit. Then, a second rabbit is created by calling the clone method on the first rabbit. To test that the age field has been copied correctly, the method then prints out the ages of both rabbits. If I run this application now, it prints out the age of both rabbits and shows that they are both 8 months old. So the clonable interface is fairly straightforward to use, but there are some well-documented issues with it. A lot of these issues are explained in detail in Joshua Bloch's book Effective Java. One problem is that the clone method is actually a method of Java's object class, not the clonable interface. The clonable interface does not actually declare any methods at all. The purpose of an interface is to define the behavior of a class, but the clonable interface has no methods to define this. A common opinion is that the clonable interface is not well documented and does not serve much of a purpose. There are other ways to create copies of objects, such as with copy constructors. Another alternative is to write your own clone method. Secondly, the clone method only creates a shallow copy of an object. It works fine if all the class variables are immutable fields or primitive values, but if they are mutable values, problems start to appear. However, despite these problems, the clonable interface is still worth knowing about. It is still one of the most common ways to implement the prototype pattern. Problems can arise with the clonable interface when classes have fields that are mutable. If the field types are primitive values like string or int, there will probably not be any issues. But if the field types are other classes, then there may be problems. In this example, there is a class called rabbit and another class called person. The person class has a field called name and methods to get and set the name of the person. The rabbit class has fields for age and breed and also a field called owner, which is of type person. The setOwner method in the rabbit class takes a parameter of type string and creates a new person object whose name is the string. The rabbit class also has a clone method that creates a copy of the rabbit it is called on. In the main class, a rabbit object is created. The owner of the rabbit is set to a person called Sally, and then a second object called rabbitCopy is created, which is a clone of the first rabbit. It then prints out the names of the owners of both the original rabbit and the cloned rabbit. If I run the application, it shows that they both have the same name, Sally. If the name of the cloned rabbit's owner is changed to Steve, the result is quite unexpected. I am calling the getOwner method on the copies rabbit and changing the owner's name to Steve. I am only making the change to the copied rabbit, not the original, but if I make this change and then print out the names of both owners again, the output shows that now the owners of both rabbits are called Steve. The name of the original rabbit's owner has changed too. This is a problem. The cloned object should be independent of the original, but changing the clone changes the original too. This is because they still share the same person object. This problem can be solved by modifying the clone method. Firstly, the person class also needs to implement clonable. It then also needs to override the clone method. The same as with the rabbit class, it creates a new person by calling super.clone and casting the returned object to person. Next, in the rabbit class, the clone method also needs modifying. The owner of the cloned rabbit should be set to a clone of the original rabbit's owner. I need to add a line of code that sets the rabbit's owner. It is assigned the result of calling owner.clone. This means that the cloned rabbit still has the same owner as the original, but it is a cloned version of the owner rather than the exact same owner. If this program is run again, the output will be different. After changing the cloned rabbit's name, the original rabbit's owner will still have the same name. The cloned rabbit is now owned by Steve, but the original rabbit is still owned by a person called Sally. Using owner.clone has meant that I have not had to use more memory by creating a whole new person object from scratch. This is how the prototype method can be modified to accommodate mutable objects.